Hi, this is Mrs. Rondeau. We're going to be talking about exponent and radical review. There is your essential question. Feel free to pause the video to write that down. I'm going to go ahead and continue on. You guys should have this on your notes paper from Google Classroom. You can either have it printed if you want, or you can make your own Google Doc or click it for a Google Doc version and you can type it in. That's fine as well. Here we go. We are looking at some vocabulary for exponents. So the first word here we have is base. So that is the bottom number when we're talking about exponents. And for example, I have 3 squared, or 3 to the second power. The 3 is the base. Then we have exponent. That is the small top number. And for example, with the 3 squared, the 2 is the exponent. Then we have power. This is the same, in terms of how we write it, is the same as an exponent. For example, again with 3 squared, or 3 to the second power, 2 is the power. So this part here at the bottom should be on your page there. Let me make that just a little bit neater. We have an exponent, or power, tells you the number of times to multiply the base number. So for a slightly different example, if I said 4 to the 5th power, a little bit, 4 to the 5th power means I am supposed to write or multiply 4 5 times. So this 5 tells me how many times I'm multiplying a 4. So this would be equivalent to 4 times 4 times 4 times 4 times 4. So how many times I'm supposed to multiply the 4. All right. Forward. So a couple of quick practice problems. We are supposed to rewrite each of the following with an exponent. So basically I'm going to go through and count how many x's am I multiplying. I have 1, 2, 3, 4, 5 x's. So this will be equivalent to x to the 5th. X is the number I'm multiplying, and I'm doing it 5 times. Then on to example 2. In a similar fashion, we're going to count them up. This time we have 2 different variables, so we're going to count them separately. I have 1, 2, 3 g's. So I'm going to say g to the 3rd. And then I'm going to go through and count the h's. 1, 2, 3, 4, 5, 6 h's. So that would be h to the 6th. And they are multiplied because the entire expression was multiplied. But since they're variables, we don't necessarily have to write the dot, but you may write the dot if you like. All right, now let's take a look at some radicals, specifically looking at square roots. So square roots are represented by a radical, which is this symbol. That's the symbol. And they also specifically ask what number times itself equals. So this symbol, when you see it, means what number times itself equals, and then that number inside. So for example, the square root of 16 would say what number times itself equals 16. So that's kind of how that works. And sometimes we are able to answer that, like we could probably answer what number times itself is 16. That would be 4. So sometimes we can easily answer, and sometimes it doesn't work out so nicely. And so we're going to look at how to simplify when it doesn't work out so nicely. So here we go, simplify the radicals. This is kind of what some people express some need to practice. So we're just going to do a little bit of practice with simplifying. So the way that I will tell you to simplify radicals is to basically pick two numbers that will multiply to make the number that you're starting with. So you can break it down to any two numbers that multiply, in this case to 48. So I could do 4 and 12. I could do 2 and 24. I could do 6 and 8. It doesn't matter what pair I start with. As you get better at this, if you can pick a number that's a perfect square, like 4 in 4 times 12, if I pick that. So if I did 4 times 12, 4 is a perfect square. That would make my life a lot easier. It's a bit shorter, but I'm going to show this first one just picking one that I don't necessarily have a perfect square. So I'm going to do 6 and 8. So I break it down into 6 times 8. Then I'm going to continue breaking down until I've broken it down as far as it will go. So 6 I can break down into 2 and 3. When I try to break down 2, I can't. It only breaks down into 1 times 2, which is basically the same as just saying a 2 here. So once I get as far as I can, I'm going to circle that end number. And then same thing with 3, it won't break down, so I'm going to circle it. Then I'm going to go back to my 8 and break it down. That would be 2 and 4. 2 can't break down. 4 will break down into 2 and 2. So once I've broken everything down as much as I can, and I've circled all my end results, I'm going to focus on those numbers that I circled. And I'm looking for 2 of a kind, any pair of any number. So I have a couple pairs here. I have a pair of 2s. So once I find a pair, notice I crossed them out. I'm going to write it in front of a square root. Okay, so it takes 2 of a kind to bring 1 out. So I had a pair of 2s, so I get a 2 out. I have another pair of 2s, so I get another 2 out. The 3 is left without a buddy, so it stays inside the square root. The numbers out front, these are going to be multiplied, so my final answer would be for, root 3. For root 3. So I mentioned if you can do a, I'm going to scooch this up just a little bit. If you can do a perfect square, that it tends to go a bit faster. So I'm going to show that version of the same problem right underneath here. This was our answer for root 3. Okay, so the same problem, square root 48. Let's say I choose to break it down into 16 and 3. 16 times 3 is 48. 16 is a perfect square. I know the square root of 16 is 4. And then I can take the 3, which I don't know the square root of, and leave it inside. You can see I have the same matchy answer. All right, let's look at example 4. I'm going to pick 2 numbers to break that down into. I'm going to say 9 and 8. But again, you could do 6 and 12 or anything else, any other combination you want. 9 will break down into 3 and 3. The 3s do not break down further. 8 breaks down into 4 and 2. 2 doesn't break down. 4 breaks down into 2 and 2. So again, I'm looking for pairs. This time I see a pair of 3s. So a 3 gets out. I also see a pair of 2s. So a 2 gets out. And I'm left with 1 leftover 2. The numbers on the outside I multiply. And so my final answer here is 6 root 2. Then the last one, example 5, same kind of thing. Let's break it down. 45, this one I can do 5 times 9. 5 actually does not break down, but 9 does, into 3 and 3. And there is a pair, so I know I'm going to get the 3 out. The 5 is going to stay stuck, and there's my answer. And on this one, just to show you that the alternate version again on this one, if you realized that 9 was a perfect square, You could have said, I know the square root of 9 is 3, and I'm left with the 5 that I don't know the square root of. So your answer is still 3 root 5. Hopefully that helps, and you guys can jump over and get started on your assignment.